This is going to be page 435. We spent some time yesterday reviewing angles, whether they're in degrees or whether they're in radians. We need to review the definition of radians. So if I have a circle, and no matter how big your circle is, you call the radius 1. So radius is 1. And then 1 radian is the length, is the angle created when you travel around the circle equal to the distance of the radius. So basically, you measure this with your flexible tape, your fabric tape measure, and then you wrap it around the circle until you get to 1, whatever that 1 is, right? And then this angle right here is called 1 radian. The nice thing about it is both a distance and a rotation. That's the whole reason we created radians. So we had a connection between a distance and a rotation. If I asked you to walk 3 degrees, you would laugh at me and say you can't walk degrees. You can spin 3 degrees, but you can't walk. If I asked you to walk 3 radians, all you need to know would be how big is the radius? How big is my circle? That's all you need to know. Okay? Well, if I just said, Jimmy, stand up and walk 3 radians, in whatever direction you want, then there is a distance. It's associated with the circle. Now, that length can change according to the circle, but it turns out, no matter how big the circle is, this angle never changes. But there are parts in the book where they list radians as like 6.3 radians. We are only going to talk about radians in terms of pi. We're not going to say 8 radians. We would say whatever 8 divided by pi is. So divided by pi. Instead of saying 8 radians, we would say 2.5 pi radians. Because it's much easier to work with it in terms of pi. So the arc length of a circle is really easy. If I have a circle and I want to know how big is this arc, well, what do I need? I need to know the radius. So here's the radius. Let's say the radius is 3 feet. And then I need to know the angle. Well, let's say that this angle is 2 pi over 3. Well, that means that this distance here is 2 pi over 3 radiuses. Right? So how do I find the arc length? You just multiply, so the arc length is equal to 2 pi over 3 times 3. Or, thank you, the arc length formula is just r theta. That's it. Now, what would that formula be in degrees? So watch this. So 2 over 3 times 180. So the 2/3 times 180 is 120 degrees. So if I had 120 degrees with a 3-foot radius, it's kind of confusing on how to get that because, what we end up needing to do is we need to find what percentage of the whole circle I'm using. So 120 is what compared to the whole circle? Yep, 120 divided by 360, which is 0.3 repeating. What does that mean? 1/3 of the whole circle. What is the whole circle? Well, I mean in circumference. Circumference is, what's the distance all the way around? It's 2 pi r, and r is 3. So we would have to do 2 pi times 3, and then times that by 1/3, and that would give me the arc length. That was pretty annoying, right? Okay, so we never do arc length in degrees. We always do arc length in radians. So if it gives you degrees, you need to convert to radians and then use the radian formula. And actually that formula that I just wrote down, that's all it does, is it converts to degrees, or it converts to radians. And then it asks you to find it. So does it want decimals? Find the exact length. So the answer here would be 2 pi. 2 pi feet, or whatever it is. Okay, so if you look at number 82, if theta is pi over 8 and r is 6, what that means is we have a little angle here, pi over 8 with a radius of 6. What's the arc length? It's just 6 times pi over 8, which simplifies to be 3 pi over 4. That's the exact measure. Yeah, and I mean, radians were created using arc length. That's where they came from, which is why the formula is so simple. Okay, so what about number 86? Theta is 14 degrees, and r is 15, what is that, nanometers, micrometers? Some very small amount. So I need to convert this to radians. How do you do that? Pi over 180. Why do I put the pi on top? I want the degrees to cancel. And then what do I type in my calculator? 14 over 180. Don't put the pi in. So 14 divided by 180. And I get 7 pi over 90 times 15. So 7 times 15 divided by 90 is going to be 7 over 6. Okay, that's pretty simple. All right, what about the area of a sector? So I want the area just of the piece of pizza. Just this stuff. Okay. How do you find the area of a sector? Well, what is the area of the entire circle going to be? Area of the circle is pi r squared. Right? So the area of this circle is 25 pi. Okay, but we only have a portion of that. How much of that do we have? Well, we have pi over 8 out of the whole circle, which is... Okay, so how big is this angle here? 2 pi. And I only have pi over 3 of that. So I have pi thirds, that's my part, divided by my whole is 2 pi. I'm talking angles here, right? Flip and times. So 1 over 2 pi. And I end up with 1/6 what? Of the circle. I ended up with 1/6 of the circle. It's 1/6 of the area. and I get 25 pi over 6. Okay, now let's come up with the formula. So all we did is I took the area formula, 2 pi, or sorry, pi r squared, and then I multiplied that by my theta divided by 2 pi, right? My angle divided by 2 pi. What happens when I do that? The pi's cancel, and I get the area is theta r squared over 2. When you are using radians, right? Why can I not use that formula with degrees? Right, the pi's canceled. So this formula relies on the fact that the pi's will cancel. So there's a different area formula for degrees, or just convert to radians. So our formula is pi r squared over 2. So look at number 90. Theta is 5 pi over 6, and r is 13, and my area formula is theta r squared over 2. So 5, oh, do I need, hold on a second. No, that's right. That's correct. Okay. I better double check. I don't want to give you the wrong formula. I've done that before. Squared. Nope, we're right. Okay. So in this case, 5 pi over 6 times 13 squared, which is 169. And we're going to divide all of that by 2. So I end up with 5 times 169, and then divided by 6 and divided by 2, or we can just divide by 12. And well, so anything divided by 6 divided by 2 is the same thing as that divided by 12. Right? So yours would work as long as you put parentheses. So, and a lot of kids forget that, but you don't. You seem to always get that right. So math fraction, the area is 845 pi over 12. Okay. How would you do number 94? Convert to radians and then use the same formula. There is a different formula, but guess what that formula does? It replaces theta with theta times pi over 180. So it's exactly the same formula. If you look, so go back and look at 429. The area formula on 429 is 1/2 r squared theta. And then if you turn the page, example 6, it's 1/2 r squared theta times pi over 180, which just means we convert to radians. So really there's only one formula, and you use it in radians. Okay. Ooh. I don't think we want to do those. I wonder if those are going to show up in the future. Okay, turn to example 7. Example 7 says linear speed. A car travels at a constant speed around a circular track with a circumference equal to 2 miles. If the car records a time of 15 minutes for 9 laps, what is the linear speed of the car in miles per hour? Do you guys understand what linear speed means? So we have this car, and just to make sense of this, let's say that the car can't turn, can't steer. But we have a rope tied to the car, and the car hits the gas. What's going to happen? It's just going to go around in a circle, and let's say that this point swivels. Okay, so as the car travels around the circle, what is its linear speed? Well, it's not traveling in a straight line, correct? But the speedometer will tell you how fast the car is traveling, correct? And one way to think of it is, if it was going around and the rope broke, what would happen to the car? It would just go straight. It would go straight at the speed that the car is traveling. So there's an angular speed because we're turning, right? The car is always turning. But there's a linear speed. If you were to take that track and stretch it out straight in a line, then we would get the linear speed. And the linear speed is actually what the speedometer is going to show. How fast are the tires turning? Now the weird thing is, the inside tire is going to be spinning at a different rate than the outside tire, right? The inside tire would be spinning slower than the outside tire. It's covering more ground, okay? So the car would compensate that because it has a differential, and it measures the speed inside the transmission, which is probably pretty close to the average of the two tires. Okay. Yes? Jimmy? Did you say wait? Oh. Okay. All right, so the formula is the linear speed, v, is equal to the arc length traveled divided by time. Okay, so in this one, in this case, the radius is 2. Oh, no, that's not right. That's the circumference. So this circumference is 2 miles. That's the distance around the track. Okay, and then we have, it took 15 minutes to go 9 laps. Okay, and our formula is speed is equal to the arc divided by time. Well, how far did the car travel? 18 miles. How come? It went around this 9 times, so the arc length would be 18 miles. So it went 18 miles in 15 minutes. But we probably don't want minutes. We want miles per hour. So how many hours is 15 minutes? 1/4 or 0.25. So 18 divided by 0.25, which is really just 18 times 4, is 72 miles per hour. That's how fast the car traveled. Now, this might seem really confusing, but all it is rate times time equals distance. Solved for r, right? So r equals d over t. How fast you go is simply how far you went divided by how long you were driving. So they're trying to make it much more confusing than it actually is. So look at problem 96. Oops. So number 16 or 96 says, if the arc length is 12 feet and the time is 3 minutes, does it want feet per minute? I guess it does. So we end up with 4 feet per minute. That's the speed. So that's a piece of cake. Okay? And then in the next one, like 100, find the distance traveled of a point that moves with a constant speed along a circle. So in this case, it says we're traveling 6.2 kms per hour, and we're going to keep that speed up for 4.5 hours. Do we need their fancy formula? No. Rate times time equals distance. So it's just going to be 6.2 times 4.5. Yeah, because they're all different. None of them are in the same units. So it will just tell you how many kilometers. Okay. Now the next one talks about angular speed. So go to page 431. Down at the bottom there's a definition. Angular speed is defined as if a point P moves along the circumference of a circle at a constant speed, then the central angle that is formed with the terminal side passing through point P also changes over some time at time t as a constant second, so as a constant speed. The angular speed is given by omega equals theta over t, where theta is given in radians. So omega equals, that's kind of an omega, equals theta over t. And then this is the angular speed. And then this is the angle in radians. And then this is time. What does angular speed mean? But what is angular speed? Meaning? How fast are we spinning, essentially? So if you tied that rope to the car, how long does it take the rope to do a full circle? How fast is the angle changing? Now, if my rope is 10 feet long and your rope is 20 feet long, I don't have to go as fast as you do to keep up the same angular speed, right? So if my desk were the center, so if I'm here and Jimmy's there, in order to keep up the same angular speed, Jimmy has to go a lot faster than me, about twice as fast, right? Because he's twice as far away. If I move closer, then my angular speed would require a much slower linear speed. And if you're sitting at the center, all you have to do is spin. And you watch Jimmy run around really fast, right? Depending on how far away he is, he's going to have to run a lot faster than I am. Oh, you do? How? If the rod was long enough, guess it's possible. There are some other problems in there that would cause some issues. Okay. What do I do with my book? Okay. So angular speed. A lighthouse in the middle of a channel rotates its... I'm on example 8, 432. A lighthouse in the middle of a channel rotates its light in a circular motion with constant speed. If the beacon of light completes one rotation every 10 seconds, What is the angular speed of the beam in radians per minute? So we complete one rotation every 10 seconds. Okay? And we want an answer in radians per minute. So what is the angle in radians? So we're going to do one rotation. So one rotation is 2 pi. So it's going to be omega is equal to 2 pi over, how long does it take to do one rotation? 10 seconds, but we don't want 10 seconds. We want minutes. 10 seconds would be 1/6 of a minute. So times this by 6 over 1. So we end up with 12 pi radians every minute. Now, once again, they've made these formulas kind of confusing, but let's just think about it. If we can do one rotation in 10 seconds, and every rotation is 2 pi, how many radians would I complete in 1 minute? Well, that would be 6 2 pi's, right? So the formula is 2 pi divided by 1/6, but it just makes sense to say 6 times 2 pi. Okay, so we are covering, what that means is that light in 1 minute is going to complete 2 pi's, 4 pi's, 6, 8, 10, 12 pi's in 1 minute. So that's how many radians, that's how fast the angle is changing. The angle goes through 12 pi radians every minute. Okay, so that covers should we stop there? How much time do we have? Yep, we'll stop there. So you need to do 81 through 105. Nope. Oh, we actually just have one section left. Okay, we'll just do these. These are easy. So we have the formula V equals R omega, and omega equals V over R. Really, this is just rate times time equals distance. Right? Okay, so example 9. A Ford truck comes standard with tires that have a diameter of 25.7 inches. If the owner decides to upgrade the tires with a diameter of 28.2 inches without having the onboard computer updated, how fast will the truck actually be traveling when the speedometer reads 75 miles an hour? So right now, the truck has diameter 25.7. Okay. And that's in inches. So we need to find the circumference. The circumference would be, it's 2 pi r, or pi d. Pi d. So it's 25.7 times pi. And we get, the circumference is 80.73 inches. If I upgrade my tires, they are going to be 28.2 So pi times 28.2. And I get 88.59. Now what should I do? So this tire is traveling 70 miles per hour, right? So how is that going to help us? You could do that, yeah. So 75 over 80.73 is equal to x over 88.59, and then you don't even have to convert it. Okay? Or you could simply say, well, how much bigger are these? You could do 88.59 divided by 80.73. 88.59 divided by 80.73. What does 1.097 mean? They're 9.7% bigger. So all I have to do is take 75 and multiply it by this. The car would actually be going, the truck would actually be going 82 miles an hour. Or that's what you get when you do this. You get exactly the same thing. Or you could convert that into feet and find the miles per hour per feet, and then you could go back and introduce the 88.59. Now that's a story problem that we're going to go through tomorrow. So today we're going to do 81 through 113 odd. Uh-oh. Are you telling the future? Okay. Good luck.